Okay, for the final problem here in this practice quiz, we have a sigma notation, a series from 1 to n. We have to prove that we get this formula. So in other words, when we add up all these values, 1 plus 3 times 2 minus 1, in other words, all the numbers from 1 to n, that we get this exact formula. So let's write it out. We're looking at proof. It's kind of helpful to sometimes pick a side and try to get one side to match the other. Then you know you've got a proof completed. So the first term is 1 plus 3 times 1 minus 1. So that's going to be 1 plus 3 times 0, or 1. Now when n equals 2, that was when n equals 1. When n equals 2, that's 1 plus 3 times 2 minus 1, which is 1 plus 3 times 1, which is 4. Then n equals 3, you've got 1 plus 3 times 3 minus 1. 1 plus 3 times 2, which is 7. Now, for our series, what we need to do is add, put that in brackets if that helps separate all this up, all the way until n. 1 plus 3 times n minus 1. So 1 plus 4 plus 7 plus ... plus. Now, check this out. We're going to kind of simplify this a little bit. This is 1 plus 3 times, oops, I don't want that parentheses there, 3n minus 3. In other words, 1 take away 3, which is minus 2. So this is our sequence, really, our series that we're trying to find the sum for. Now the first term in this is 1. Now this is a finite series, and you might notice that we've got a common difference, which isn't really too surprising. Thinking that there's a proof, we might need a little bit better explanation. A sub n is equal to a sub 1 plus d times n minus 1. That's the formula for an arithmetic sequence. Well, that's what this is. This is the first term plus the common difference times n minus 1. So we've actually got a formula for an arithmetic sequence here. So what we can kind of do is, because this is arithmetic, we can, and we're finding the sum of the series, we're finding the series, the value of the series, we can use the formula S sub n equals n over 2 times a sub 1 plus a sub n. Now what is a sub 1 and a sub n and n? Well, n, this goes from 1 to n, so we know there are n terms, so that doesn't change. The first term is 1. The last term is 3n minus 2. Taking a closer look in this parentheses here, you've got 1 plus 3n minus 2. Well, 1 minus 2, negative 1. So this is n over 2 times 3n minus 1, which is the same as the given. So we've kind of proven that this series does indeed have this result for all positive integers n.